Yeah, so good evening, everyone. I hope I'm audible to you all. You can just react if I'm audible. Yeah, okay, fine. Okay, so as it's already 9:05, we'll start with the session. Let's other join in meanwhile. Okay, so let me present my screen. Is my screen visible to you all? Okay, okay, fine. Yeah. So I hope all of you who are present here, you have watched either the recording of the last session which I have sent to your mail, or you have attended the session. What we discussed were the basics of means what exactly you need to do if you are venturing in this field. What exactly the prerequisites or some basic knowledge which you need to have before entering or before understanding anything related to this field. I had specified some important points in the last session. So today we will directly jump into the main subset of artificial intelligence, which is machine learning. As I had already specified to you all in the last session, that artificial intelligence is basically what? Intelligence is basically the ability to reason, to learn, or to act. When we combine that with the uh, power of our computers, because intelligence is a quality which is present with us as living beings. It's not already present in the computer. We instruct the computer in a certain way, we train its parameters in such a way that it gets that ability to it gets that quality of intelligence. When we combine both, it is basically artificial intelligence. We have 3 to 4 main subsets of that. The main subset is machine learning. There is another subset which is natural language processing, another subset that is computer vision, and so on. There are many such factors, subsets. So we will start with the basics of machine learning today. uh, First of all, let's understand what exactly is machine learning and how it differs from the traditional programming which we do. I hope you all have done some sort of programming in your means till now. You have done something or the other, right? You would have done a Python code or a Java code or something. You must have done till now. So in traditional programming, what we do is we basically try to program our computer in such a way that it actually optimizes a problem. It actually gives us an output, and the logic is built by us, right? The whole logic of from the part of putting the input into your code, building the logic, and then means getting the desired output. It's totally dependent on you, what logic you frame. It's completely dependent on you, right? So what in traditional programming we do is we feed the input, we also do the programming logic by ourselves, and then we run the program to get a particular output. Okay. How it differs from machine learning is, in machine learning we feed the input as well as the output also. Okay. Because machine doesn't have a intelligence of itself. We train and then we test on a data. First of all, if there are 800 sets of data, what we do is we divide that data into a particular set of a particular split in training and testing. For example, let's say the training and testing split is 70 to 30. So 70% of the data, which consists of the input, the features, as well as the target, which is basically the output, we give it to the computer to train first. Once it gets trained, then we uh, put the rest of the data, means the 30% of the data which we separated for testing it, we provide it to the computer so that it gives us certain classification or any regression based problems or anything. After that, we evaluate its performance. If it means what is its accuracy, what is the recall score, what is the F1 score. These are certain metrics which are means used to evaluate the performance of the models. We will discuss later in detail about all these things. So basically, the main difference between traditional programming and our machine learning approach is, in traditional programming, we feed the input, we ourselves build the logic, and we run the program to get output. But in machine learning, we need to feed the input as well as the output. And there is no such logic. Means if you are, for example, if you are writing a code to print the numbers which are odd and even, what you do? You do something like that, right? N modulus 2 is not equal to 0 or equal to 0. You give a particular condition, you give a particular logic, so that we are able to segregate between the odd and even numbers. But here there are neurons. In computer, we have a set of neurons. We just need to train those neurons in a certain way that our computer achieves a logical ability or reasonable ability, as a result of which it helps us to classify something or to do or to get any outcomes or predictions. So the main difference between traditional programming and machine learning is basically this. I hope it is clear to you. If it is clear, if we can proceed forward, you can just turn on your mic and say it's okay, so that I proceed, because I won't be able to see your responses. I'm in a separate screen, right?
It's okay.
Okay. Okay, so we'll start with certain basic things which we will be using very frequently in our in the coming time, because till now I was just explaining it in a layman language so that you get to know, get to understand. As not specifying any prediction, training, target, these words. We'll just get to understand now, means what is the importance of these words in the context of machine learning, and what are these words which we should know before entering or before doing anything related to machine learning, right? First of all, the first basic terminology in this is model. What is a model? It is a specific representation learned from data by applying some machine learning algorithm. A model is also called as a hypothesis. Basically, a model is, for example, we are building a model which we intend to classify either a student or to be a dropout or to be a graduate. What we saw in the last session, right? What we did is we had some data, we cleared it, we pre-processed it, we normalized it, and then we trained, means we made ready a data set which was comprehensive, which was totally cleaned. There were not any discrepancies in our data set. Then we used, we provided that data to the computer to train and then to test. So the bridging gap in between this is a model. To whom do we give those data? We provide those data to a model. A model is basically, it consists of certain parameters, okay, which we provide, such as the learning rate. There are other factors such as the epochs, okay, the number of iterations which is needed to be done. There are many such factors which we provide, which is already present in the Python libraries. You just directly need to call those things and just need to specify the parameters, such as the learning rate should be 0.1 or 0.001. You specify certain metrics. By doing all these things, what you do is you build a model. Once a model is built, you feed the data to that model, and that model in return trains itself. And after that, we feed that those untrained data sets which we had classified, that 70-30 split. 70% of the data is given for training, and the rest 30% which is left, we keep it for testing. We provide that same model this testing data also, and then the model, what it finally does is it compares the training and testing things. By analyzing that, it gives us certain metrics, the performance metrics, such as the accuracy, the recall, F1, and all the things. So what is a feature? Feature is the, if you remember, in the last session, what we did is there were certain features such as the parental education qualifications, or the financial status of a student, the grades, the attendance status, the assignment submission status. All these are features, right? Based on these things, these are the things which are provided to our model, so that it gets to know which are the dominant factors and which are the lesser dominant factors, based on which it either provides us with a classification outcome or a regression outcome. Okay, so moving on, what is a target? A target is basically the output which we desire. Either a student is a dropout or a graduate. So that set should be made ready beforehand, which is done in supervised learning. There are many types of learnings also. We will come to that. Okay. So basically a target is something which is present, which basically intends the outcome of a particular column or a row. For example, the financial status of a student is low, the parental education of that particular student is also low, and the grades are also low. So what is the target? The target is the student is most probably he will drop out. Similarly, there will be 800 rows and there will be 800 such targets. Out of those 800 things, we will train 500 and we will test 300 so that we get to know how accurate our model is. I hope this thing is clear. And then, as I said, training. First of all, there is a model. You input certain things to it, some data to it. The model extracts certain features. These features are then compared to the target labels. This process is called as training. And once the training is done, when you test the untrained data, the testing data, the model provides you with certain predictions. I hope these 5 basic terminologies are clear to you. If it is clear, you can turn on your mic, and if you have any doubts, you can ask. So that we move forward. Yeah, any doubts? You have any doubts regarding these things? I'm audible to you, all right?
No, bhaiya.
Okay.
Yes.
Okay. Okay. So for more simplification purpose, let just make you see the data set so that it's clear. I hope you can see the screen. This is the same data set which which you all had seen in the last session. Gender, age, attendance, assignment, submission. What are these? These are the features which we talked about now. What is this? This is the target column or the output where our outputs are present. Okay. So this is a complete data set, and this data there are about 800 to 1000 column rows of data. This data is fed into a model. When this data is fed into a model, we divide a certain proportion of the data to either be trained and a certain proportion to be tested. This is called as the training process. Once the training process is done, it gives us certain outputs or certain outcomes which we ask of the model. Okay, that is basically called as prediction. So these are the 5 basic terminologies which you should be clear before proceeding further. So moving next, yeah, there are basically here three are written. There are 4 types of learnings. First is the supervised learning. Second one is unsupervised learning. Third one is semi-supervised learning, and the fourth one is reinforcement learning. Okay, there are 4 types of learnings basically. So what is the difference in between all these things? See, if the basic term learning means what? Learning means it is a process by which our computer means the data which we feed into the computer, it analyzes by it gets into the intricate patterns of that, and it tries to analyze a particular set of patterns inside the data. It tries to learn the data. Okay, basically what we do, what we all are doing here, we all are learning a particular thing, right? Similarly, machine is also trying to learn a particular thing when we provide certain data to it. As I am teaching you now and you all are listening now, I am feeding you certain data and you all are listening. You all are getting trained for now. Okay. Similarly, the model does the same thing. We feed certain data into it and it learns. So there are 3 to 4 types of this kind of learning. The first one being supervised learning. So what is supervised learning? See, here if you can see this Excel sheet, if this data set, what it does is there is a user ID, there is a gender, there is age, there is salary, and there is a column purchased. So what are these things? These are features. Okay, this is a complete data set, and this is the output label. In supervised learning, what we have is we have this labeled data present with us beforehand. Okay, this is the target outcome. This is the target level for similar to the one that graduate and dropout also, that is similar to it. We have a target column already present with us before entering to the training phase. Okay, this kind of a learning, when a labeled data set is already present with us, which has both the input and output parameters, is called a supervised learning. In this type of learning, both training and validation data sets are labeled. This is already present with us. Okay, there is nothing which is not present with us. We have everything with us. We just need to provide certain data for training and segregate certain data for testing. Simple, nothing else. We already have everything with us. This is what is known as supervised learning. There are then two kinds of supervised learning. Okay. First one is either we classify a particular thing. Second thing is either we try to get certain value. Okay. For example, see this one. 0 1 0 0 1 1. What it basically gives you an idea. What idea it basically gives you, right? 0 and 1 we are classifying, right? Either a thing is 0 or 1. For example, either a student is graduate or dropout. We have two options. Either he's if we means label the thing of graduate as to be 0 and dropout as to be 1. If a student is graduate, we label it as one hot and coded 0 or either as 1, 0 and 1. There are only two options. But there can be many things while we do prediction tasks, right? Machine learning is not only concerned for just classifying a particular thing into either as yes or no. There are many other things. We can predict air quality index of a particular city at a particular time also. Air quality index cannot be yes or no, right? In Delhi, the air quality index may be around 400, 500. But in Amravati, it may be around 70, 80. So what are those? Those are certain values, right? We cannot classify that it to be either as yes or no. That is not a classification task. What that kind of task is called as, that type of task is called as regression. For example, if you have scored 90, 80, 87, 85, there are 4 subjects as part of your curriculum. You have scored certain scores, 90, 85, 87, 88, something like that. Okay. Then our task is to predict what will be your score in the 5th subject. Okay. I'm giving a very generalized example. So what we do is, that is not a classification task, right? I cannot say that you will get pass or fail. I am asked what score will you get in the 5th subject. That is what that basically deals with values. Values are continuous values. That may be anything. It can be 0 also, it can be 100 also, it can be 70 also, it can be 60 also. So these kind of tasks are known as regression. And the ones which are basically which deals with certain things, means we know the finite number of things to which we should classify. For example, color can be either blue, green, gold, red. There are 4 things. That is called as multi-class classification. Okay. If there are only 2 things with you, either yes or no, pass or fail, those are called as binary classification tasks, where the means where there are only 2 things concerned with you. When there are multiple things concerned with you, that is called as multi-class classification. Okay. For example, Gmail also. You can, if you open your mail, you can see, means there are sections, right? One section is social, one section is promotion, one section is updates, offers. There are similar sections like that. Some of your mails get into the spam category. Okay. These are certain categories. And by categories, what do we mean? We know that these are the 7 to 8 things present with us. The mail is classified into one or the other thing. It is not a regression task. A regression task is when you want to predict a wind speed or air quality index or certain scores of your mark. That is basically a regression task. Okay. So I hope this is clear to you. If you have any doubt, you can ask. Okay. If not, we can proceed further. If till now, if everything is clear to you. Okay, so I hope, yeah, it's clear. Okay. Okay, so these are certain examples of supervised learning algorithms. So linear regression, I hope all of us have done this anytime in our life. If in 10th, 12th, or if now also, if you all have applied statistics as a subject, you for sure, this is a sure question, linear regression. This is a 10-mark question. You will definitely get it. Whatever subjects you will study from now on, if there is maths or any calculation concerned with it, linear regression will be the one for sure, because that is the very basic thing from where you just you go on to the advanced level. Okay. So first of all is linear regression. There is another machine learning algorithm called nearest neighbors, naive Bayes, decision tree, support vector machines, and random forest. Okay, these are certain examples. We'll go into depth of this as we move forward. So similarly, what is an unsupervised learning algorithm? Okay. Supervised learning was what? We had a labeled data set with us already. May it be a classification task or a regression task. Okay. If we wanted to classify certain air quality index, we already had that with us, that Delhi's air quality index is this, Chennai's air quality index is this. We already had all the data with us in a labeled form. In unsupervised learning, the thing is we don't have any labeled data with us already present with us. Okay, it is the training of machine using information that is neither classified nor labeled and allowing the algorithm to act on that information without any guidance. So we don't have any guidance. We just have certain data, input data with us. We don't have any output data. Okay, it is your responsibility to predict a particular outcome. It is the machine's responsibility to predict a particular outcome. Okay, so how this is done? Okay, there are mainly again two types of unsupervised learning. One is clustering and one is association. Okay, a clustering is where you want to discover the inherent groupings in a data. Okay, such as grouping customers by purchasing behavior. For example, let's say in a supermarket, mainly these clusterings are used there. In a supermarket, you means the team, the data team or the machine learning team, they have been given a task to identify a particular set of customers who try to uh, purchase maximum things from the section who try to buy a particular biscuit or something, right? There are means many different items in a supermarket. Okay, so the one which is most frequent, okay, the one which is bought most frequently in a supermarket, if the supermarket authorities have that idea beforehand, they can accordingly they can means customize their orderings, right? They can keep certain things more or certain things less based on the demands. Okay, that is mainly called as demand marketing, what it is called. Okay, let's say there is a X biscuit, there is a Y biscuit, there is a Z biscuit. Okay, you know these three things are there with it is present in the supermarket. The supermarket authorities, after tabulating everything, after analyzing the data, they got to know that Y biscuit is bought more frequently than X and Z. Okay, so they have got an idea here that X is an item which is frequently bought among these three biscuits. Okay, they may be cream biscuits. Okay, there may be another data another sets of biscuit which is only concerned with cookies. Okay, then there are three types of cookies, A, B and C. After analyzing the data, they again got that B is bought more frequently than A and C. Okay, that is again another grouping. Similarly, there are groupings made. Okay, there are groupings made, there are clusters made. Okay, by analyzing a particular set of inputs. This is called as clustering. Okay, so one very famous clustering algorithm is K-means clustering, which we will okay, get to know today only. We'll go through that K-means algorithm. And for association rules, there is a priori algorithm. Okay, a priori algorithm is basically you will have a set of data. Okay, once you will also be given a minimum confidence. Okay, minimum confidence means what is the means how much probable it is that this event will occur. Okay, so you will have certain data, you will have some minimum confidence percentage. What you will do is you have to after calculating the frequent sets. That's a very long process. I'm just trying to give you an idea. It is not required as of now. We will study later on if it is required. Okay, so there will be a data set, there will be certain frequent data sets. Okay, what you have to do is you iteratively have to check on which is the most frequently occurring data set. Based on that, you have to tabulate all the possible combinations. For example, there is a biscuit X, Y, and Z. Okay, the value of X is 4, the value of X is 5, the value of Z is 6. We have got a value that the threshold should be 5. To progress with the algorithm, the threshold should be 5. So as X is the value of X is 4, we won't consider it. We now have only two values, Y and Z. Okay, so what are the possible combinations which we can get? One combination, we can get only one combination from here on, right? That is Y and Z. Then there are two possible relations from association which can be possible. One is Y implies Z and one is Z implies Y. Okay, you will then what you will do is you will there is a process which is involved when you have a particular set of values which will be there in your numerator and denominator. It's a very long process. Once you get that fraction value, you will compare it with the confidence value. If your value which you got is greater than the confidence value, then there is an association between those two variables. If the value is lesser than the confidence value, then there is no association between those two variables. This is what a priori algorithm is. This will be You will study this as you go on further. I have just given you a very basic idea of this thing. Okay. So, okay, the most basic disadvantage of any supervised algorithm is the dataset has to be hand labeled. Okay. This is a very costly process because it is very time consuming. Costly in the sense doesn't necessarily mean it is about money. It basically is means how difficult it is making or how time consuming it is. Okay, that is basically called a costly process. But you have to also see the other part of unsupervised learning is that there is not much application of unsupervised learning. It has very means limited application, such as what we saw in the supermarket and these stuffs. Very limited. Mainly, supervised learning has a more relevance as compared to unsupervised learning. Means it is more widely used. Relevance means both are equally relevant, but it is more widely used than the other thing. Okay. So yeah, just wait a minute. Okay, I'm just getting an important call. Just wait a minute. Yeah, yeah. Sorry for the inconvenience. Okay. So is it clear till now? Or any doubts you have? If you have any slight doubt also you have, please clear it, because these are basic things. If you have idea of these things, you won't face any difficulties when you will be getting into any subjects, because there will be 4 to 5 major subjects which are concerned only with these things. You will get 100 marks of FAT based on these problems only. So if you have any doubts, feel free to ask and clear it now itself, so that you have all the ideas. Okay, so okay, it's clear, I think. So we'll proceed. Yeah. So we learned till now what we learned two things. What is supervised learning and what is unsupervised learning. The third thing is semi-supervised learning, right? So there are certain disadvantages of both the things. The concept of semi-supervised learning was introduced hence. Okay. In this type of learning, the algorithm is trained upon a combination of labeled and unlabeled data sets. Okay. If you can see this diagram, okay, this is the model. This is a labeled set of data, and this is an unlabeled set of data. This labeled data is fed into this model. Okay. So we train the model first with the labeled data. Labeled data basically means it has input, it has output, it has both the things present with it already. So once you feed the labeled data to this model, it is trained now. Okay. Now this model has achieved certain sense of intelligence, that is called artificial intelligence, AI. It has achieved certain sense of intelligence now. What we do is there is an unlabeled dataset also present with us. We use the intelligence of this model to predict the outcomes of this unlabeled dataset. Okay. Since this model is trained now, it has some intelligence associated with it. We use this model to get outcomes of this unlabeled dataset. So when we get certain outcomes of this unlabeled dataset, we tell that as pseudo labeled data. Okay. So there is a pseudo labeled data with us now, and there is another labeled data also present with us. So now what we do is we feed both of them into the model again. We retrain the model, the pseudo data labeled data sets and the labeled data which was already present with us, to refine our model more and to get more good results based on more diverse data. Okay. Since the data shouldn't always be limited. If you are training your model with a only limited set of data, there is a chance that your model may fail when there is a diverse set of data. For example, if you have trained your data to only if there is a student dropout prediction model, and if you have trained your model only on basis of two factors, that is grades and assignment submission. So when the attendance status is taken into consideration, your model will fail, right? It won't be able to recognize properly because there is another feature added which was not recognized by your model. Your data was not diverse enough. So when you will again train the same model with the attendance status, there is a greater chance that there will be any conflicts. maybe a student may have good attendance and their parental education level is also good, but because you train the data on the basis of only grades, okay, only grades or assignment submission, that a student is getting lesser grades and he is not submitting assignments properly, the machine may classify based on those two factors to be as a dropout. But we also need to see all the other factors, right? Attendance is also a major factor concerned. Financial status is also a major factor concerned. So if your data set is not diverse enough, you won't be able to get a good result. Okay. So in means what we do in semi-supervised learning is there is a labeled data. We train the model. There is an unlabeled data set also present with us. Okay. Which will be having the same kind of features as the labeled data, but it won't have any outcome associated with it. By using the intelligence of this model, we predict the outcomes of this. Means we get make this unlabeled data set as labeled data set. Since it was not labeled beforehand, we term it as pseudo labeled data. Pseudo is basically what it means. It is in a sense imaginary. Okay, it is in a sense we assume, which is given to us by the model. It was not already present with us. If we had a data already present with us, we can say 100% definitely that it is a data set and the data are correct. If it is given by a model, I also said in the last session, a model may give accurate data or may not give accurate data. So we cannot directly say that it is a 100% perfectly labeled data. That's why we term it as a pseudo labeled data. Okay. This pseudo labeled data with the labeled data already present with us, we retrain the model again to get better results. Okay. So in semi-supervised learning, labeled data is used to learn a model, and using that model, unlabeled data is labeled, called pseudo labeling. Now using whole data model is trained for further use so that we get good results. I hope this is clear to you. You can just turn on your mic and say if it is okay. I'm not getting any responses. Are you all listening or I'm
Yes,
just
Bhaiya,
saying?
it is clear.
Okay. Okay, yeah. Please respond. Else I'm just feeling that I'm just talking to myself. You all are not means getting clear about the concepts. Yeah. Okay. This is just a graph. Means the same with whatever I have repeated till now. This is just represented in a graphical format. Okay. Intuitively, one may imagine that the three types of learning algorithm is supervised learning. Okay. Let's take an example. There is a student who is under the supervision of a teacher. Okay. At both home and school. That is basically called what it basically it is called a supervised learning, because you are a student, you are under the supervision of a teacher both at home and also at school. Okay, so your learning is taken care of as whole. Your learning is taken care of. In unsupervised learning, what the thing is, student has to figure out a concept himself. Okay, you don't have the means luxury or privilege of a teacher who can guide you. You have to figure out yourself. There is no labeled data with you. Okay, in supervised learning there is a teacher who can guide you. In unlabeled data there is nothing. You have to guide yourself. And in semi supervised learning, the thing with you is there is availability of teacher in class, but you don't have a teacher at home to make you learn or like that. Okay, so you have certain few concepts you can understand in class, and based on your understanding of those few concepts, you apply it to get to know certain concepts which you're reading at home. Okay, so this is what uh, uh, if in very brief thing, if you want to analyze this thing, this is what supervised, unsupervised and semi supervised learning is. Okay, so as I said, regression is a statistical measurement. It is basically used in finance, investing, and other disciplines that attempt to determine the strength of relationship between one dependent variable and another independent variable. I hope you all have heard about this equation. Okay, y is equal to fx. Okay, what is x and what is y in this case? Can anyone say which is a dependent variable and which is an independent variable in this case? I hope all of you have studied relation and functions anytime in 10th, 12th, or now also. You should have some basic idea about that, right? If I'm not wrong, you can respond.
fx is a dependent variable and y is independent variable.
Sorry, I couldn't hear you.
Fx is a dependent variable and y is independent variable.
See, I'll let you know what the thing is. Okay. We have y is equal to fx, right? X is a set of values. Okay. X may be means 5 values, 10 values, 15 values, anything. Okay. F of x is what? Basically, it is a function which is already present with us. For example, the fx is x square plus 2x minus 1. There is an equation like that. Okay. What the thing is, the value of your y, okay, the value of your y is always dependent on the value of your x. Whatever you feed, the x value, whatever you feed, for example, there is an equation x square plus 1. If you have fed x is equal to 5, then your y value is equal to 6. Okay, is equal to 26, because x square plus 1 means 5 square plus 1, 25 plus 1 is equal to 26. Okay, I hope you got to know how the dependence and independence work here, right? So basically regression means we basically use regression in tasks. As I said you earlier, we use it basically in the task where we want to predict a particular value. This is not dealt with classification problems. These are based with regression based problems. Okay, both the things are different. So the main task of regression is it establishes a relationship between one dependent variable and a variable which keeps on changing. Okay, which keeps on changing, which is an independent variable. Okay, so dependent variable is one which is already present with us, and the independent variable is one which is always changing. It is a series of changing variables. Okay, so we will get further. There are mainly two types of means we will be studying here mainly the two types of regression: simple linear regression and multiple linear regression. Because the other things means, if you can see in the screen, the decision tree and the random forest regression, what these things are, these are basically these decision tree, random forest, their algorithm understanding is required. Okay, when you are dealing with any means classification or classification task, mainly decision tree, random forest, these are used basically for classification. Okay, linear regression, since means it is linear regression is very simplified thing. There is only linearity associated with the data. Okay, main applications of this is mainly the simple and multiple only. So we will study the things. Okay, simple linear regression models are used to show or predict the relationship between two variables or factors. Okay, as if you can see this, what this is, y is the dependent variable. Okay, b naught is the constant, and b1 into x1 is the independent variable. Okay, so the simple linear regression models, what they are used to, it is used to establish a relationship between two variables, as I think Raj said. Okay, so f of x is an independent variable, y is the dependent variable. Okay, the factor that is being predicted is called the dependent variable, and the factor that are used to predict the dependent variable are called independent variables, since the independent variables constantly change. Okay, so I hope this is clear to you, right? Whatever I said till now.
Yes.
Okay, okay. So let's see this one. Okay, this is a data set. Similar kind of data will be given to you in your exams as well. Okay, whatever exam, if you get the question of linear regression, this kind of data set will only be given to you. That is for sure. Not this much. This is basically, these are 3 to 4 factors are there here in your university exams and semester exams. If linear regression question is asked, there are only two things. Two factors are given. One factor may be the student ID or something. Other factors may be marks. They will give 7 data. They'll ask you to predict the eighth one based on the other 7. Okay, so here if you see this, means we are seeing in a very broader view, there are 4 things associated with here. Okay, CO2 emission is the thing which we want to predict. Okay, what these 3 are called and what is this called in simple machine learning terminologies, which I told you just few minutes back. Can anyone answer? What are these 3 things and what is this thing? You can turn on your mic and respond. Okay. Only if you answer, I'll know that you are getting clear. Else means I'll just go on speaking. If you won't know anything, there won't be any use of me teaching and you learning. So you can just turn on your mic and say, what are these three things called and what is this thing called in machine learning terminologies, which there are only 5 terminologies which I have taught you today. Okay. So what are these three things called and what is this called? You may be wrong also. There is no problem in it. You just try to speak up.
I think these three things are called labels. No, means the features, and that one
Yes,
thing
yes.
means is called target, or we can say
Yeah.
label.
Yes, yes, very good. Yeah, these three things are called features, and this thing, that is the CO2 emission, this is called as labels, or this is the output. These three are features. Okay, we have certain features which we provide to the model. It extracts certain features and determines which is dominant or not dominant, or if we also want, we can make one factor to be more dominant than the other features. Okay, these are the features, and this is the target column. Based on this, we will proceed forward with our tasks. Okay, you can see linear regression. You will always see there will be linear. The means the line will always be like this because the data should be linearly separable. Okay, the main thing of linear regression is the data should be linearly separable. For example, if you can see, these are 8 data points. Okay, these are 8 data points. What we try to mainly intend is we predict the CO2 emission with engine size feature. Okay, this is the engine size, this is the CO2 emission. What is this? This is a feature and this is our target. Now, as we are doing linear regression basically deals with two factors, as I said you. In your exams also, you'll get only two things. One column will be input thing, other will be an output thing. They'll give you 7 to 8 set of data and they'll ask you to predict the 8th one if the other 7 are given. Okay, so you can see here, we are asked to predict the 9th data here. We already have 8 data with us present. When you will plot the data, when you will plot the corresponding x and y, okay, when you will corresponding x and y, you will find that you will get a straight line which will be linearly separable. So if to get this value, there is a simple formula associated with linear regression which you will study. I hope means that I shouldn't discuss now because you will forget anyways. You will forget the if I discuss now, you will forget. To better, I'll say I have also given a handbook in the group. Okay, whatever is taught now, after this session, you just go and refer there. There the specificities and all the details are there. Refer that, make notes. If there is any formula, write it down and finish it then and there only, so that you are clear with the concept. No need to again means spend time by you watching any YouTube videos or doing anything for learning the same thing which you have invested time. You are investing 1 hour time right now, right? So every minute counts. Every minute is very precious in our lives. So if you're learning something, learn it dedicatedly so that it gets finished in 1 hour. Okay, and you don't need to overcomplicate a simple concept because these are the set of input values. This is a set of output values. You have two values, for example, x and y. There is one simple formula. It is sigma xy minus sigma x sigma y by sigma x square minus sigma x whole square. You will multiply n with the thing. Okay, I'm verbally telling the formula, so you won't understand exactly if I'll verbally say the formula. You can refer the handbook which I provided in the group, make the notes and finish it now itself, so that your work is done easily. Okay, so I'll explain you the coding part because the mathematical part, as I said, there is only one formula associated with it, and there is no difficulty in this particular concept. So I'm not getting into that formula part since it's very easy to apply directly. Okay, if we'll go in such detail, we won't be able to finish anytime soon. Okay, so I leave it on you. Just you have one formula to remember, and you have to apply the x and y. Nothing else. Nothing else. You only have to tabulate the sigma x, sigma y, sigma xy, okay, sigma x square. Only these 4 things you have to put it in the formula, finished. Nothing else is there in this. So I'm going into the coding part. If you can see, there is a sklearn package present in Python. From this package, you import linear model. Okay. What you do next is once you have imported the linear model, you means you associate a variable, okay, with the linear regression model. Okay, this dot linear regression basically it suggests that you have now initiated the linear regression model. Okay, for regressor, for means getting any output or outcome, what you need is you have x and y values. Okay, so you have stored it as an array, the engine size, and you have also stored the list of values as an array of the CO2 emissions also, because we are only concerned with engine size and CO2 emissions. What you will do is you have initiated the model here. Okay, you have initiated the model here in this line. You have given this train x, and you have given this also train y. What you do is now you fit these two datas into the regr.fit. This dot fit function is used to means feed the data basically. Okay, it is used to fit the data since you are only concerned with the engine size and CO2 emissions. Once you do this, you will get certain you will get a coefficient and you will get an intercept. If you know the equation y is equal to mx plus c. Okay, so what is means you will from there you will get the coefficients and the intercept, which is basically the equation of linear regression also, y is equal to mx plus c. I hope till now it is clear to you. Multiple regression is basically extension of simple regression, where the thing is, in linear regression, you had only one variable with you and you had one outcome to predict. Now you have a combination of variables with you. You have a combination of features with you and you want to predict a particular thing. Okay, so the formula becomes slightly different, and rest thing remains the same. Okay, here also the coding part, what you can see, the same thing. What you did is you just included another parameter here while training x. X is always the things which you input, y is always the things which you get as an output. Y is equal to fx, what I said. Y is always the output variable, x is always the input variable. In general cases, wherever you will see, this will be the thing. Okay, so what you did in multiple regression is you just fed two more, means one more, or a combination of like that. You can give 3 to 4, 5, 6 things you can give. Okay, in multiple linear regression, you basically give a combination of features and you predicted the CO2 emissions. Rest of the things are same. Again, you are fitting the train x and train y, and you are getting certain coefficients and intercept. Okay, is this clear to you till now, or there is any doubt, any confusion? Okay, all of you are clear? Only one thumbs up, so rest all did not understand. If you don't understand, tell me. I can explain it again also. I don't have any issues. Main thing which I need is the clarity from your side. If you don't get the clarity, there is no purpose of me teaching. Okay. Still, I got 7 to 8 thumbs up, but still, if I don't know if some people have just turned on and have left. Okay, it's your wish. I can't do anything. Okay. Okay, thank you everyone who have responded. Yeah. Okay, so to summarize all the things, what it basically, the pros and cons are: linear regression works on any size of data. Okay, and the main problem with it is we are mainly assuming things in linear regression. Okay, we are assuming that one means if the engine size is 2, the CO2 emissions, which is means if I show you this, okay, these things are based on assumptions. We don't exactly know if the data which we are doing is, if it is completely 100% true or not. Okay, in polynomial regression, it also works on any size of data set, and it works well on non-linear problems also, polynomial regression. Okay, the means cons is you need to choose the right polynomial degree. Okay, because if you choose more polynomial degrees, means x cube, x4, x5, what it will do is, the more the polynomial degree variable will be. Okay, if you all know basic differentiation, what we do in d by dx of x square is, the d by d of x square is 2x, right? D by dx of x cube is 3x square. D by dx of x cube is 3x square, and x4 is 4x cube. So there are means when your polynomial degree increases, what it does is it takes more time to for the means the model to actually differentiate it. Differentiation is basically what? Finding out the slope. If you all know the basics of differentiation, you are finding out the slope when you are differentiating a particular thing. So as you are differentiating more number of times, that means if your polynomial degree is x to the power 5, that means it will take that much amount of time for your polynomial equation to converge to its local minima. Okay, I hope you are understanding. If you can imagine a U-type graph, okay, what you are doing is you are trying to converge it to a local minima. So the more means increased your polynomial degrees, the more number of differentiation it will take you, and the more time complexity it will have. Okay, basically everything what we do, what we work is dependent on time complexity. The main thing behind your DS is you are optimizing a particular thing. If your thing is not optimized, then again you will get into troubles. The main thing which we are trying to do everywhere is optimization. Okay, so if you don't choose a particular polynomial degree, because for larger data sets, okay, maybe you can use an increased polynomial degree, but for smaller data sets, if you are using increased polynomial degree, that will just increase your time complexity but won't do anything. You have to choose a polynomial degree which will balance your bias trade-off. Okay, bias and variance trade-off, which is a particular very famous thing. I have asked, I think, everyone about this during your interview as well. It is a important interview question as well. Okay, so the rest other things, the support vector, the decision tree, and the random forest, we will study when we get into the classification problems. For now, I am not going into all these things because these are basically used. They are used for regression, no doubt, but mainly for regression task, there are advanced concepts also. But if I don't tell you the algorithm behind the decision tree and random forest, and if I go on just explaining you about how regression is done, you won't understand anything. So let's first finish that classification thing. I'll tell you the algorithm, how it works. Then you can relate it to regression. It will be better because the things are similar. Only thing is that is a classification problem. It is a regression problem. Okay. So let's move into logistic regression. Logistic regression, if you remember in previous slides, that was our first supervised learning algorithm. Okay. In statistics, logistic model is used to model the probability of a certain class or event, such as pass, fail, win, lose. Okay, anything. Okay, the logistic regression can be used for your binomial as well as multinomial classifications also. You can do binary classification as well as multi-class classification in it. So how it does is how it works, I will tell you. Suppose we use linear regression for a problem to either predict a person, either he is detected with tumor or not. Okay, what we do is we can use linear regression, no doubt. We can get a particular threshold value also. For example, let's say if the threshold value is more than 0.5, we will classify that person to either be detected with tumor. If it is lesser than 0.5, we'll classify it that he is not detected with tumor. Okay, so this is how binary class problems look like. But what if we had a very small number of data which actually suggested us that suggested about the tumor part? Okay, this is called imbalanced and balanced data set. I have asked this question to some of you during the interview as well. If your data set is not balanced, okay, if you don't have a good proportion, a balanced proportion of both the data which you're trying to classify. For example, we are trying to classify a student either to be a graduate or dropout. If we have 700 data of graduate and only 100 data of dropout, for sure, because that is an artificial thing, our machine is an artificial thing. Since 700 is a very majority number as compared to 100, okay, it is a very dominant number as compared to 100. Most probably, the classifications it will do will be directly as graduate. There will be ambiguity in your data since your data set is not balanced. Okay, so what do we do in such a case? If we had only one case of tumor and rest 4 cases of not tumor, if you have only 5 data, there is a greater chance that your classification won't be as good as it should be. So what logistic regression does is it actually keeps the value between 0 and 1 only. In linear regression, you can get any value. As we did here, you can get any value. If this is 2.0, it is 196. If it is 2.4, it is 221. If it is 1.5, it is 136. There may be any values. Since the values are larger, to get to a particular threshold, you need to look after many things as well. Okay, you directly cannot say that we can keep 230 as the threshold, and above this we can classify into one class, below this we can classify into one class. Okay, since the values can be of a bigger range, it will be difficult for us. So what logistic regression does is, it basically reduces our this kind of a burden by only limiting the value to 0 and 1. Okay, we use sigmoid function here. This is the formula of sigmoid function: 1 by 1 plus e to the power minus z. Okay, since you have you have a denominator beneath 1, your value will always be ranging from 0 to 1 only. It won't exceed that, because you have 1 plus e to the power minus z, right? So e to the power minus z, you whatever value you get, it will always get added to 1. Okay, 1 plus e to the power z, 1 plus 0.1, or 1 plus 0.2, or 1 plus whatever value you get here. Okay, it will always be within 0 and 1. So what this does is, it always generates a value either to be it generates a value from 0 to 1. What then we can do is, this main thing of sigmoid function, how it looks like is, okay, you can see here it starts like this, and after 0.5 it goes on like this. You can see how the graph changes. Okay, we have a clear demarcation at 0.5. So whatever values we get below 0.5, we can easily classify it to be under one category, and whatever values we get above 0.5, we can classify it to be another category, either to be a 0 or 1. Okay, did you understand that, or any confusions? Yeah. Okay, others, did you understand, or is there any kind of confusion? If there is any small confusion also, please let me know, so that I accordingly okay. Okay then. Okay, so the main purpose behind using the sigmoid function was to limit it to 0 and 1. So that means, what is done is, you have that demarcation with you already. You can classify the values pertaining to lesser than 0.5 to be either as one category, and values greater than 0.1 to be other category. As simple as that. I'm not trying to make it more complicated. Okay, since I'm providing the introductory stuff, the basic stuff to you all, the next thing your duty is to explore more about it. Okay, so if as you keep on exploring, you will get to know more things about it. Okay, there are many things, many classifications which are done using this also. This is the basic algorithm, but from basic only, whatever advances in machine learning field we are seeing, it started from a very basic thing only. So the researchers kept on exploring the things from very basic level and reached a particular advanced level. So your task also is to do the same thing. If I am teaching you the introductory stuff, the next thing which is your duty is, you need to go up till the advanced level. Not advanced level also, but you need to start exploring things. You just can't listen this and yeah, I got to know something, and if you will stop, you will stop. You won't start anywhere in your you won't find that motivation to do something or work for something. But once you get into this, you will feel that rush within you to grow and learn more things, because it will be of some sort of interest to you if you are keen on exploring this field. This is what I can suggest. Okay, so yeah, let's move on now to the next algorithm, which is the k nearest neighbors algorithm. Okay, so how many of you have heard about Euclidean distance here? Euclidean distance or Manhattan distance. Has anyone heard of this previously? Yes, Nandan?
Manhattan distance.
Okay, you have heard about it, right?
Yes, yes.
Yeah, okay. What is Manhattan distance?
Well, both algorithms do have the same thing, right? The Euclidean algorithm and Manhattan distance. Like they were used to calculate the distance between the 2 points. That's it.
You are not clearly audible. Means it's the background noise is too much.
Yeah, I apologize for that. They were both using for like calculate the distance between the 2 points.
Okay. I'm not able to hear you properly, but yeah, okay. If you know, it's very good. I'll let everyone know again what is Manhattan means. The distances. Euclidean distance is basically what you means the distance. If you have got see, for example, let's say a region is one, meridional thing is one. Okay, you have these two features with you. This is a data point and this is a data point. You have, for example, you have certain such kind of data present with you. So you all have done, you would have surely done this thing, x2 minus x1 whole square plus y2 minus y1 whole square whole root over. That is what your Euclidean distance is, if you remember this. Okay, this is the most basic thing. If you have read the means the in 10th standard, if you have read about that distance chapter, I hope you have done this anytime in your life. X2 minus x1 whole square plus y2 minus y1 whole square whole root over. Okay, this is what our distance, Euclidean distance is. Manhattan distance is basically the absolute difference between two data points. Okay, if there is a data point region, means the region is a feature and meridional status is a feature, we have the value here to be 2 and the meridional, the value of meridional to be 1. Okay, basically that, if you, the absolute difference between these two things is what? Mod of 2 minus 1, right? If there was, if the result was 1 minus 2 also, if you take mod, it will always, you will always get a positive value only. Okay, so Manhattan distance is basically the thing which you did there, x2 minus x1 whole square plus y2 minus 1 whole square root over. Manhattan distance is basically mod of x2 minus x1 plus mod of y2 minus y1. Okay, these are the two things which is actually used, which are mainly used. Means there are many other metrics also where distance which is used to calculate distance, but these are the two main things which are actually used. And the k nearest neighbor thing is mainly dealt with distance based. It is completely a distance based thing only. What you do is, you have a data set with you. There is a value, means there are 3 to 4 values with you. Okay, x1 x2 means y1 y2. For example, let's say there is a data set, data point with you, x1 3 comma 4, x2 4 comma 5, x3 5 comma 6, x4 7 comma 8. There are set of 10 values like that. Okay, you are asked to means to find the if the value of k is given to you is equal to 3 or 4, it is given to you. Okay, you are asked to find the, means to which category it will belong. Okay, to which category it will belong. If I can, yeah, can you see this formula? This is what your Euclidean distance is called. Okay, if I can, means I have a question. Okay, so I'll make you see directly that, so you get clarity. Just wait a second. Yeah, I hope my screen is visible to you. Okay, see this one. Okay, this is our paper actually. Oh, this is our ML paper, what we have got. You need to apply, this is a kind of data set which will be given to you, which is mainly you deal with when you try to implement in a coding part also. This is how your data set looks like. This is a very small set of data. Okay, we have bigger data sets when you deal with the coding parts. Okay, so see here, what basically the question asks you is, apply KNN to this data set to predict the class level. Okay, these are certain classes. You can see one class is underweight and one class is normal. From these data sets you can see, you are given a condition that the height should be 170 cm, weight is 57 kg, and the class you need to predict. Okay, you are given a k value to be is equal to 3, and the distance you are instructed to use the Euclidean distance here. So first thing which you should know is Euclidean distance. Okay, Euclidean distance is what? This is the formula for Euclidean distance: x2 minus x1 whole square plus y2 minus y1 whole square. Okay, similarly to the whole root over. You will get certain values after you take out the distance. You will get certain distances after you calculate the things. So if we see here, what we are given? We are given the height to be 170 and the weight to be 57 kg. Let's assume this is our this we need to predict, right? This we need to predict. Let's assume this to be x and x1 x2 and this to be y1 y2. What we will do? We will calculate the Euclidean distance of each and every point which is present in our data set. Okay, so the height is 170 here, the height is 167 here. So what you will do? This is 170 minus 167 whole square plus 57 minus 51 whole square whole root over. Okay, you will get a particular data after this, right? Like this. We'll get something like this. We'll get 11.87. After again, if you will go to the next data, 170 minus 182 whole square plus 57 minus 62 whole square whole root over. Again, you will get a particular value. Similarly, if you will go to the third data, 170 minus 176 whole square plus 57 minus 69 whole square whole root over again. You will get another distance. So based on that, you will get how many data are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 data are there. You will get 10 distance values. Okay. You are given the k value to be 3. You are given the k value to be 3. What you will do is you will find the you will find 3 values. Okay, the first 3 values, if as it is asking you for the k is equal to 3, you will be finding first 3 k values. Let's say you have got distance to be 11.87, one distance to be 11.89, and one distance to be 12.23. Okay, that distance, the class corresponding to the distance 11.87 is underweight, the class corresponding to the distance 11.89 is normal, and the class corresponding to the distance 12.01 is also normal. Okay, so out of the 3 things, which is the majority one? Is the underweight class majority or the normal class, or the normal class is majority? Out of the 3, for the distance 11.87, which you calculated using this 2 value, you got a particular distance, and that distance is also associated with the class, since these 3 are one group, right? So you have got distance based on these 2 values, and this is the class associated with these 2 values. So you know the particular set of distances and the particular set of class it is associated with. There are 3 values here, there are 3 values here. Okay, out of the 3 values, you got 2 values to be normal and 1 value to be underweight. This is called as majority voting. This is a concept called majority voting. The class which has got more votes than the other class, okay, that is called to be as the majority class, and the and this phenomenon is called majority voting. Based on majority voting, what you got is there were 2 votes for normal and 1 vote for underweight. Okay, so the class which will be classified, which this data will be classified will be normal. I hope you understood the algorithm. Did you understand, or should I repeat it once again? Surely all of you understand, or should I repeat it once again? Because I think there may be any confusion to some of you. You please feel free to open your mic and speak. Okay, we are here to learn only. We're not here to just shy away from things. You are part of GDG because of this only. You want to learn something and you want to get some clarity, you want to get some guidance, right? So if you have any small doubt also, open your mouth, open your mic and ask. There is no hesitation. Okay, since I think there was no asking of anything, we should move. Okay, this is how the KNN algorithm works. Okay, K nearest neighbor. There is also an algorithm K means clustering. That is clustering. Okay, clustering is dealt with unsupervised learning. Now we are dealing with supervised learning. Supervised learning, K nearest neighbors. Unsupervised learning, K means clustering. Okay, clustering is different. It is associated with unsupervised learning. Classification, regression, these tasks are associated with supervised learning. I hope these things are clearer to you now. Okay, so this is the same thing which I repeated to you. Data points that are near to each other are said to be neighbors. It is based on this paradigm. Similar cases with same classes labels are nearer to each other. The distance between two cases is a measure of their dissimilarity. Okay, so you can use Euclidean distance to find the similarity or dissimilarity. Anything. Okay, so we'll pick a value for k, which is already given in, which was given in the question to us. We calculated the distance. We searched for the k observations in the training data that are nearest to the measurements. We predicted the response from the most popular response value, which is called as majority voting. Okay, it may be asked for 2 marks or 3 marks to that what is majority voting and how it is used in KNN. So you will just specify this. There are two parts. You have to select the k value and you have to compute the similarity. When you did this, okay. So this is a graphical representation, means this is the value, the nearest neighbors. Okay, it is just demonstrating the same thing only. I hope you can graphically also analyze the same thing, because we are predicting one value which is nearer to the rest three values, because of which you means voted, the majority voting was done and you were able to classify that particular thing. I hope you all understood this thing. Okay. So yeah, the general solution. These are the same things. The advantages of KNN is there is no training period of this. Okay, KNN is called lazy learner. Okay, instance-based learning. It does not learn anything in the training period. It does not derive any discriminative function from the training data also. Means if you can logically think this part, we are just calculating the distances. Okay, we are just calculating the distances, and based on distance we are classifying a particular thing. So is there any kind of training which we are doing here? We are not doing any kind of training here, right? We are not splitting that 70-30 data, we are giving it to the model and then we are asking it to train itself and then to provide us certain outcomes. No, we are calculating the distance. Based on that distance we are trying to classify a particular thing. Okay, that is called instance-based learning. Okay, it is learning, but not in that conventional way in which the machine learning models do. That's why it is called lazy learner. It is also a key thing. It can be asked anytime. Anyone can ask you. So it's better if you keep knowledge of these small things. Okay. This also makes the KNN algorithm faster than other algorithms, because others do require training. Other algorithms do require training. For example, SVM, what you do in SVM is you means mainly you draw a hyperplane. Okay, you draw a hyperplane which segregates two classes, the positive and negative classes, that requires extensive training also. So those algorithms are slower than this KNN. Okay, since it requires no training before making predictions, new data can be added seamlessly, since it is basically just taking out the distance and it is giving us the outcome. So we can add data also. There won't be any problem regarding the balance and unbalance of data. As a data maker, as a data set maker, you should be responsible and careful enough to categorize the data and to label it properly. Okay, your task is more important than the model's task here, because the data which you will feed, it will basically revolve around it. So for small data sets, okay, for small data sets or for data which you have, means you have complete knowledge of a data set that it is correct, you can use KNN algorithm to be the best algorithm, since it doesn't require any extensive training, and you don't need any much expertise to work with this particular thing. It is very easy to implement also. There are only two parameters, the value of k and the distance function, nothing else. Disadvantage is it does not work well with larger data sets, as I said you. For larger data sets, there may be, because cost basically means not the money. Okay, cost in terms, in computational terms, in computer terms, cost is basically dealt with how much time does it take. That is the biggest problem of our computer area. Okay, we are means we deal with computational tasks. We don't deal with money task and term it as costly. The more important part for us is the how much time does it take. Okay, so in large data sets, the cost of calculating the distance will be too much, since it is only calculating distance. If you will give 1 lakh data, how much time will it take to calculate one data and then classify? It will take much amount of time also. So the cost of calculating will be too much. Does not work well with high dimensions. Okay, higher dimensions means as you increase the number of features. Okay, higher dimensions means number of features are increased. 2-dimension means you had means you just had one data. You have 2 data and 1 output. 1-dimension you have 1 data and 1 input. 3-dimension means you have means the number of factors keep on increasing as the dimensions keep on increasing. So if the dimensions keep on increasing, the computational time will be more. As the computational time will be more, the cost will be also more. And since this is a very simplified algorithm, there may also be a chance that it may not intricately analyze the patterns hidden inside the data. So it may not work well with high dimensions. It is sensitive to noisy data, missing values and outliers. As I said, the main responsibility of this kind of, when you are trying this kind of algorithm, it is your responsibility mainly as a data set maker to analyze, to make sure that there are no missing values and outliers, since this is a very simplified algorithm and whatever you do is directly it calculates the distance and predicts us a particular, it gives us a particular outcome. Okay, so these are the certain things and this is how you implement this. Okay, as I said, sklearn.neighbors, this is a package. You import K-neighbors from it. Okay, you initialize this model. These are already present inside the Python packages. You just need to call all these things. You gave the K, this is the K value, and neighbors is equal to 3, basically is the K value you gave here. This is the X and your Y value. It may be more values. This is just for demonstration purpose. There may be many more values to it. Since we are dealing, means I'm just demonstrating you. This is the X value, this is the Y value, this is the K value. What you did is you initialize the model here and then you fed the data here, X and Y. And then you just call this K, you just try to print this value. This is the value where you fed it. You use the dot predict function here. You gave a data. You gave a random data to it. Okay. You got this class to be 0. Okay. And then you use this predict probability function to get to know about the possible, yes, the possible probabilities of this data point belonging to either to 0 class or 1 class. So you can see 0.6667 is the probability of belonging it to 0 class, and 0.33 was the probability of it belonging to class 1. Since it has greater probability, it belongs to the 0 category. Okay, so this was how the K-neighbor classifier algorithm basically deals with. You, for every algorithm, this is the same thing. You have this sklearn package. You need to import that particular classifier which you are trying to implement. Then you will initialize that. You will fit the X and Y, means that is the test and that is the input and the output things. After that, you will use the predict or the predict probability or the classification metrics. These are functions which are already present. Just need to call them and you will get to know all the the metrics associated with it, so that you evaluate how well your model performs. This was up to KNN. I think we'll stop here today. Tomorrow we'll look on the other things. Okay, we'll continue with the rest of the things tomorrow. So if you have any doubts, you can ask me now, or if there is no doubt, you can leave. Just fill the feedback form. Okay, it is there in the group already. You can fill the feedback form. If you have any doubts, you can ask me. You can stay back and ask me. There is no issue. Okay, if you don't have any doubts, you can leave. It's already time.
Where can you share this PPT in the group?
Yes, I will share.
Thank you.
Yeah. Yeah, Nandan, do you have any doubt? Okay.
No doubt.
Okay.
అరే వాడు అటు సైడ్ వెళ్తున్నాడు.